I will go in more detail on what element, molecule, or compound is, but pure substance is the opposite of a mixture. So, for example, water can be a pure substance if it just only contains H2O molecules. Iron, if it only contains iron atoms, it can be a pure substance. So a pure substance only contains one thing in it. That thing can be repeated several times, but it's only one type. So the ratio or the compositions are definite, meaning they don't ever change. So atoms are pure substance. They're the smallest unit of matter, made up of protons, neutrons, and electrons. Keeps its physical and chemical properties. For example, one atom of gold would still have the properties of gold, such as being malleable, lustrous, etc. So elements are pure substance. It's also a pure substance. Elements are made up of only one type of atom. They cannot be broken down into simpler substances found on the periodic table. Chlorine, lead, gold, and are examples of elements. So the difference between an atom and an element. I believe I'll use this definition. So oxygen. What would elemental oxygen be? Would it be a single atom? Or would it be more than one atom? How many, to be precise? O3? So you breathe in O3? What do you breathe in? O2. So oxygen contains two atoms of oxygen, oxygen atom. That's how it's found in nature. We would say that's elemental, depending on your definition, that's sometimes called elemental oxygen. It'd be better to say molecular oxygen, but it's sometimes referred to as elemental oxygen. In nature, oxygen is never found by itself. It always comes in pairs. So elements can combine in chemical reactions to form molecules. So here we have oxygen and hydrogen elements bonded together. So hydrogen exists as H2, oxygen exists as O2. Both of them only contain one type of atom. Oxygen contains only oxygen, hydrogen contains only hydrogen. So and they make molecules. Note that the O2 and the H2 are actually molecules themselves. A molecule just means it has more than one atom. So molecules and compounds are pure substances. When elements chemically bond together, it creates molecules. Molecules can be the same element bonded together or many different types of elements bonded together. For example, two hydrogen atoms bonded together creates the H2 molecule, or when you have carbon, oxygen, hydrogen bond together to make a molecule of sugar. So both of these are examples of molecules. The H2 and the sugar molecules. Compounds are a subclass of molecules, or special. Some molecules are called compounds. Compounds are molecules that are made up of more than one type of atom. So H2 is a molecule because it's more than one atom, but it's not a compound because it's the same atom repeated. In order for it to be a compound, it has to have more than one type of atom, such as hydrogen, oxygen, and carbon for the sugar molecule. All compounds are molecules, but not all molecules are compounds. And remember, when answering a question, or asked if sugar was a compound or a molecule, it's both. But which is the better answer to say? There's a multiple choice test. So if I said, is sugar a compound or a molecule? Technically, it would be both a molecule and a compound. But in a multiple choice test, you answer with the best answer. Compound is more specific, so you would say that it's a compound. It's technically a molecule too, because all compounds are molecules, but compound is more descriptive. So some compounds have scientific names. You don't have to write this down. It's just random chemicals. Carbon dioxide, iron 3 oxide, sodium chloride, sodium bicarbonate, hydroxyl aluminum sodium carbonate. Now we have mixtures. They are not pure substance. They are made of two or more substances that are not chemically bonded. Each substance keeps its own identity. For example, air is a mixture of different gases, nitrogen, oxygen, and various others. Ocean water, a mixture of salt, water, and other chemicals. Soil contains gravel, plant material, dirt, and other things. Trail mix contains a lot of various stuff. They're not chemically bonded together. You can separate the salt from the water. You can actually separate the nitrogen and oxygen from each other. In soil, you can pick out the rocks, discard them. There are two types of mixtures: heterogeneous mixtures and homogeneous mixtures. We're actually going to go over a little bit more than just two, as we have some in-betweens. But a heterogeneous means you can see different parts. Hetero means different in Greek, so can see different substances. So genius means throughout, I believe. So trail mix, Italian dressing, soil. You can actually physically see everything, the individual parts. Homogeneous mixture appear to be the same throughout. You cannot see the individual parts. So air, you can't see the nitrogen versus oxygen. Salt water, you can't see the salt from the water. Lemonade, you can't tell the lemon portion from the sugar and the water. It all looks the same. A homogeneous mixture is also called a solution. You might have heard this expression before, creating a solution. What that means is you're making a homogeneous mixture of various chemicals. So we have matter. Matter can be broken down into pure substances and mixtures. Pure substance can be broken down into elements, compounds. I would say elements and molecules can be further broken down into compounds and non-compounds. Mixture is homogeneous or heterogeneous. So you can have individual atoms of an element, molecules of an element, molecules of a compound, mixture of elements in a compound. Everyone good? So again, if you want a better definition or an alternative definition, so mixtures are two or more substances that are not chemically combined. The substances in the mixture retain their individual properties. Solutions are a special kind of mixture where one substance dissolves in another. So a solution is where something dissolves in another material. Elements are simplest form of pure substance. They cannot be broken into anything else by physical or chemical means. Pure substance that are the union of two or more elements. They can be broken into simpler substances by chemical means. So flowchart, if it's uniform throughout, homogeneous. If it can be separated by physical means, it's a solution, not it's a pure substance. And if it can be decomposed by chemical means, compound element. So if the answer is no, the matter is heterogeneous. It's considered the least mixed, does not appear to be the same throughout. Particles are large enough to be seen and to be separated from the mixture. Sand and pebbles, oil and water, powdered iron and sulfur are examples of heterogeneous. Granite is a heterogeneous mixture. You can see different portions. If it's uniform throughout, leads to another question. Can it be separated by physical means? For example, salt water. Can you separate the salt from the water by physical means? You can boil away all the water and be left with just salt. You can convert all the H2O into a gas while keeping the salt solid. So that's a physical way. You did no chemistry on it. Again, phase changes are just a physical change. Eventually, the steam will recondense back into a liquid, and you have separated the salt from the water without chemically changing either. The particles that make up the mixture are very small and not easily recognizable. So examples of homogeneous mixtures are toothpaste, mayonnaise, milk. One of the reasons why I chose this PowerPoint is to talk about colloids. Colloids, and a colloid, the particles are mixed together but not fully dissolved. The particles are relatively large and are kept permanently suspended. It's a substance that is between heterogeneous and homogeneous. It is closer to being homogeneous, the same throughout, but it's not quite a solution because it's not one thing dissolved in another. So, for example, milk is considered a colloid. It has fat that's been blended up into small particles, and the fat stays suspended in the mixture. It can somewhat separate, and you might see like a watery layer on top of your milk or a different type of layer where some of it has separated out. True solutions were completely 100% homogeneous. A fog would be an example of a colloid. The water vapor is suspended in the air, but it's not truly dissolved because you can definitely see patches of more dense and less dense areas. So just like a homogeneous solution, a colloid would not separate upon standing. The particles are constantly colliding, and this allows colloids to scatter light, because colloids often seem very cloudy. True solutions are transparent. So like water, they're transparent. Colloids will usually give away the fact that they're colloids and not true solutions by the fact they look cloudy, such as milk. You can't see through milk very well, so it's not a true solution. It looks cloudy because that means that it's colloid. But unlike heterogeneous solutions such as salad dressing, is not going to separate into different layers. milk is colloid. There is going to be some breaking down of the proteins, which causes it to spoil. But I don't mean separating the layers by that. I mean just by settling naturally. So a solution is a type of homogeneous mixture formed when one substance dissolves another. It is the best mix of all mixtures. A solution always has a substance that is dissolved and a substance that does the dissolving. The substance that is dissolved is called the solute, and the substance that is dissolving is called the solvent. So ocean water is a solution. The universal solvent is water. Water actually can dissolve most of everything. It's called the universal solvent because of its property. We often measure whether or not something can dissolve in something else by actually testing it with water to see how much that substance can actually dissolve into water. Many liquid solutions contain water as a solvent. Ocean water is basically a water solution that contains many salts. Body fluids are also water solutions. You can have several different types. So the solvent and solute, the solute could be a gas dissolved into a gas. This would be like air. Oxygen and nitrogen is what we're breathing. You can also have a gas dissolved in a liquid. Soda water has carbon dioxide dissolved into the water. You can have a solid dissolved into a liquid. Salt dissolved in water. You can also have solid dissolved in a solid. Unless it's on the periodic table, if you hear a metal that's not listed on the periodic table, that's usually going to be a solution, such as bronze. There's no element on the periodic table called bronze. That is because it's copper with about 12 to 12.5% of tin added to it. Brass. Brass is copper and zinc. Steel is usually iron with a little bit of carbon in it. Usually in these cases, whatever has the highest percentage is the solvent. It dissolves the other metal. Air is a solution of oxygen and other gases dissolved in nitrogen. Here we say that they are dissolved in nitrogen because nitrogen makes up 80% of air. Stainless steel is a mixture of iron and chromium. Brass is an alloy of copper and zinc. Collectively, for metals, they're known as alloys whenever you mix two or more metals together. So an alloy is a solution. So if it can't be separated by physical means, it's either an element or a compound or a molecule. Elements are the simplest pure substance. An element cannot be changed into simpler substances by heating or chemical process. The smallest particle of an element that has the properties of that element is called an atom. An atom is the basic building block of matter. There are more than 100 known elements in the universe listed in the periodic table. These elements combine in such a way to create millions of compounds and molecules. All elements are made of atoms. Atoms of the same element are like. Atoms of different elements are different. So basically, periodic table, invented. Compounds are also pure substances, but compounds are made of more than one different type of element. Water is a compound, it has hydrogen and oxygen. It can also be broken down into simpler substances. Again, these PowerPoints miss a lot of things. Definition I really want from this. So compounds, an element. So the elements that make up a compound join in a specific ratio according to their masses is one way of defining a compound. So for example, you could have a billion oxygen and 2 billion hydrogen. That's a ratio of 1 oxygen for every 2 hydrogen. That's water. So compounds have a constant ratio between the elements. We just usually write the most simplest one. Technically, all the H2s are bonded together. It's not just one hydrogen and or one oxygen and 2 hydrogen. It's actually millions and millions and billions of oxygen and hydrogen all bonded together. It's just the simplest unit is the molecule H2O. The compounds just have a specific ratio that is held constant. This is so a solute is the substance that is dissolved. Solvent is the substance in which the solute is dissolved in. So you say salt is soluble in water. When two liquids or gases for a solution, the substance of greater volume is a solvent. So, or it also include if you have two solids too. And An aqueous solution is a solution in which water is a solvent. An electrolyte is a solution that conducts electricity. Non-electrolyte is a solution that does not conduct electricity. Water is one of the best things that prevent electricity from flowing through it. If you have pure H2O, no electricity can go through it. However, if a tiny bit of salt is mixed into it, it becomes an electrolyte. It means it allows electricity to conduct through it. Unless you physically remove all the ions from water, it's really hard to find water that's pure. You can almost never find pure water in nature. You can assume all water from your tap or rain has something mixed in with it, which makes it an electrolyte, or a weak electrolyte at the very least. Saturated solution is when a solvent cannot hold any more solute. So if you were to continue to add sugar to tea, there's a point in which the sugar no longer dissolves in it. Three factors that speed up dissolving: temperature. Higher temperature means more will dissolve easily. Stirring and particle size. I really wanted to go over solubility later. I'll probably come back to this. Suspensions. This is like the only one that has suspensions in it. It's a mixture in which particles or material are dispersed throughout a liquid or gas, but are large enough to eventually settle out. So, for example, if you were to go take a cup of mud, eventually the dirt molecules will settle to the bottom, and you have a clear layer of water on top. If it stays undisturbed, this would be a suspension. If you shake up salad dressing, it temporarily becomes a suspension. It looks homogeneous, but eventually it'll separate back out into individual layers. Whereas a colloid is a mixture in which the particles are dispensed throughout, but are not heavy enough to settle out. They cannot be separated by filtration. The particles are too small, but it's also not a true solution. So milk, jello, fog. Yeah, I'm almost done. Homogeneous has the same current properties throughout it. Heterogeneous, different components people seen. I think that's we're done. I'll post these PowerPoints on.